Oops. Let's go ahead and do that in here. So if matrix A there will be a little problem though, because we do have to do the checks as well. Yeah, so it's only going to get in here if j plus 1 is on the map, but I also need to check if n is on the map. So if n, let's see, I'm adding 1 to it. If n is less than or equal to 8, then if matrix A, because we have to check this before we check matrix A, and even though we're checking both of those in the subroutine anyway, the subroutine lets us move, remember, it lets us move to a space, an empty space, but we only want to attack if there's a position there. So we have to say if matrix A of ON, if the fractional part of that, exists. Just like that. Excuse me. Yep, so if the fractional part of that matrix exists, which should only check if it's safe to check, then we do our little subroutine. Yep, and that should work. And then here we do another one. So after this one, we'll have 2 more ends. Whew, this is getting so long. If then, and here we go. We have if n is greater than or equal to 1, then if matrix A, or if the fractional part of matrix A exists. So of ON. Yep. Okay, so remember, even if it exists and it's your own team, it still won't return anything from the subroutine if it's your own team member. So that means the pawn should correctly be separated from other players. So now when I press this, it should only do the one in front of me, which it does. Let's see here. Let's move this one up. And then let's move this one up. And let's do this one up. And good. Well, wait a minute. Okay, so we kind of have the problem. Why does it say 1? Well, let me just go over it one more time just to make sure. Yep. So it thinks we only have 1 move when we have 2. And that's an issue. It should think that we have 2 moves. I don't know why it thinks we have 1. Did I add 1 to C? I'm supposed to add 1 to C in the subroutine. If I add 1 to C, I'm going to be very confused. And I didn't add 1 to C, okay. Okay, so if it's a correct move, we're going to add 1 to C. And I don't think I add 1 to C anywhere else in here. Okay, so that works. Kind of. We do need to add it to the list, to list 1, list 2. Because when we remove it, remember, when we cancel and when we move, we need to remove all of those 2's, all of them. So after we add 1 to C, we have to add to list 1 and list 2 we have to set their values to be O and N. So list 1 would be the X, so it would be the N, and list 2 would be the Y. Okay, so now we have two lists, or both. We stored the value in both the lists so that we can go back and clear them as needed. So we're going to go back up here to where we press the green button, or the green button should be the green button should work. Actually, the green button should work, but but when we move, that's the one we need to fix. So here's where we move. We update it. We set our new N and O to be printed. We update our pretty much everything. So where do we subtract 2? Do we subtract 2? Or do we not subtract 2 when we move? Well, when we move, we're putting our new value there. So so we need to subtract 2 before we put our new value there. So before we take the negative ji and store it into the yx, that's when we subtract 2 from the list. And it won't matter if it's the one that we're overwriting, as long as we do it before. Because we're just going to overwrite that value anyway. But we want to also overwrite all of the other ones. So we sort of have to... You know, I don't know if I can use B here. Can I use B here? I don't know if I can use B. It's not a subroutine, so... I think B is an option to use as a variable here. So for B is 1 to C. Oh, my bad. We want to subtract 1. So we want to take matrix A of list 2C, or B, sorry, comma list 1B, right? And we want to subtract 2 from it, right? And then we want to store it back into matrix 1, or into matrix A, list 2B, and then list 1B, right? I think that's how we need to do it. I think that'll work. Oh, and we need to update. Oh, great. Hold on. I totally forgot about something. Where do we press? Let's see here. When we press A is 31. Okay, here's where we press A is 31. So if we press the green button, let's copy how we do it there. So we minus 2 from in this loop. Okay, so we have a B from 1 to C. Okay, so we store them as N and O, and then we call them, we subtract 2, and then we store it into P, and then we call the subroutine, and then we output the new string. Okay, so it's a little bit of code, but it's okay. We'll just put that where it belongs, because this is the code for where we're doing stuff. So we might as, I mean, we're not using N and O, are we? Do we store? Okay, so N and O. You see, we call N and O down here to show where we like moved to. Oh no, but does this matter? I think that's the one we're updating though, I and J. Yeah, I and J stores N and O. So yeah, that takes care of that. Because this is one. Once we move, the only thing we need to update is everything but where the cursor is, because the cursor doesn't. I mean, it's the cursor. Although the funny thing is, what this might do is this might actually write over the cursor, unless the cursor gets drawn over this. I'm trying to remember how that would work. I think the cursor gets drawn last anyway before we go into the input loop. Anyway, we can store, so list 1 C, or B, sorry. We can store that as, that's the X value, so it's N. List 2 B, store as O. And then we can use P here. So ON minus 2 stores P. Oops, it's not a P. And then we store P into matrix A, N, and O. Right? Okay, so now we have N, O, P set, we have the matrix fixed. Now we can output by calling label 0, so we can do our for loop. For D is -1 to 0. If D go to 0, end, and then we output. So we output at ON string 1. And I think that'll work. Because now for all the moves we update, right? So if I'm here and I move up, something's wrong here. Hold on. Something's wrong. I think I switched an X and Y or something. I must have. Did I say O and N? Yeah, O comes before N. Oh, that's okay. I know what I did wrong. Where is it? It's at the bottom of this. Right here. Right here. Okay. By the way, this is 2n minus 1, not n. Yep. Anyway, back to the game. Okay, so there's a string up there, or there's our destination. We selected it. Let's move this guy. Select, move him down. And we're going to move you up. And we're going to move you down. And we're going to move you up. And what just happened? Where did the piece go? Where did the piece go? So I think I just accidentally deleted a piece. Oh great. No, okay, so this one can't move forward, it can move to the right, which is correct. I don't know what happened to that piece though. It shouldn't have disappeared. That was not good. Yeah, that shouldn't have happened. I don't know. Why did that piece disappear? Okay, he's got 2 moves. That's correct. Why did that piece disappear though? Something's not right. I move up. That's not right. That piece shouldn't have disappeared. Very strange. So let me move this guy up here. What? Now that piece disappeared. No! I hate bugs. Why did that piece disappear? It's not supposed to. It's bad if a piece disappears when it's not supposed to. It's really bad. Okay, I moved it down. I don't know why it disappeared. It should be able to move there. Why doesn't it move there? It should be able to move there. Why? Why doesn't it move there? It's a 1.1. It should be able to move there. That's a valid move spot. Why would it not? Something's wrong with my code, that's for sure. Which is scary because I don't know what it is. Something's wrong with the logic. Okay. Let's figure this out. Okay, so what is this? If A equals 31 and F part of Q. Okay, that's the cancel. I'm not worried about the cancel. Not worried about the cancel. If A equals 21. Okay. So here's where some of our problems are coming in. It's either here or the subroutine. So matrix AYX stores P, if F part of P and Q equals int P. Then we do this. Okay. If F part. So if there is a piece there, and if there's a piece there and it's not, and it's our own, Okay, then we select it. Got it, got it. P is greater than 1. Okay, that means like we're on the black, we're the black player. If j plus 1 is less than or equal to 8, then if not f part of a, j plus 1 I, then, okay, so if there's no piece there, then we can consider moving forward. And then here is where we have j plus 1, O and n. If n is less than or equal to 8, then if there is a piece there, we call the subroutine. If there is a piece there, we call the subroutine. Okay, we never call it here, do we? Okay, so it should only work for black pieces moving down. But it should work. This takes forever. Oh, that deleted it. That deleted it. Something deleted it. Something deleted the white piece. That's really awkward. Something overwrote that piece. I'm not sure how or what, but something overwrote it. So it just disappeared, like something. I'm not sure what happened, but something overwrote that piece. And what overwrote the piece, though? I gotta find out what overwrote the piece. I gotta find out. And when you walk over it, that'll tell you for sure what's there, because that goes straight from the matrix. I mean, the subroutine tells you exactly what's there, right? So the 1 is still there, see? When I moved it there, I move on and off, I can see if it's still there, okay? If I move this piece there, okay, let's see if it's still there. Nope, it's gone. Okay, so it has something to do with moving the plus down with our new code here. Okay, so the problem is in our a equals 21 branch. Where's our a equals 21 branch? Where is it? Where's our a equals 21 branch? Nope, that's the subroutine. Where is it? What am I doing? Is this it? I think this is it. Yeah, okay, so if j plus 1 is less than or equal to 8, don't tell me I store 0 into the matrix in the subroutine. I thought I got rid of that line. I hope I did, because yeah, that is not a moving subroutine. There should be no 0 store. Yeah, I only add 2 to P. So see, matrix A, ON stores P, right? And then I can add 2 to it and store that back into matrix ON, but that's the most that I do. I just add 2 to it, and that's it. I don't do anything more. Okay, so the problem shouldn't be in the subroutine, because I'm assigning P. In this subroutine before I even call my 0. So yeah, the problem shouldn't be there. Let's go back to here's where we write zeros, but we should only get this code if we moved. Oh, wait a minute. This might be the problem. I have I had NO here instead of ON. That might have been the issue. That could have been it. Yeah, because you never swap coordinates like that, or you're gonna have problems. Yep. So there we go. ON. Hopefully this will work. So I move up. I move down. I move up. I move down. Okay. Now I select him. Select him. Oh wait, no, okay, sorry. I have to move this guy first. Ready, and select. 2 pieces to move to. Woohoo! And let's say I move here. It clears the other piece. Oh joy. Oh joy. So I can move this piece up here, and then this guy should only have 1 piece to move to. Oh joy. It works. It works. This guy should have 2 spots. Oh, but no, he shouldn't, because I didn't implement the white to do it. Alright. That's cool. Man, pawns have to be, if you're not doing anything else, if you're not trying to implement the other hard parts of the game, pawns are like the first complicated thing that has to be different from everything else. Oh, I'm complaining here, aren't I? So let's go ahead and just do the white pawns and get them out of the way, and then we can go ahead and try to do the rest of the pieces. So yeah, let's do the white pawns here. Where do we subtract 1 from J? It's here. So it's going to be within this thing. So it's 1, Now we're in 2. Back in 1 again. So we're going to do it here, I believe, because this if statement is saying if there's nothing in front of us, right? Okay, so, but this statement, we're going to say, so if, and we're going to check if there's something, if I plus 1 exists is, so if I plus 1 is less than or equal to 8, then end. And we're going to do this again. If I minus 1 is greater than or equal to 1, then end. Okay? And we're going to do 3 more. Whew. If matrix, or actually, wait, no, we have to store them into N and O, don't we? Yeah, N and O. And it doesn't matter if we do that after, who cares? Or you know what? Just to keep it conformed, screw it, let's do it the same. So I plus 1 stores N, J minus 1 stores O, and we just have to check if N is less than or equal to 8, not that it's a big deal, but just to keep it looking like the other code, if I plus minus 1 stores N and J minus 1, which hopefully J minus 1 didn't change, or J didn't change during that whole time, but I don't know. It is in its own scope here, and it's 1 line, so, or it's a constant number of lines. So it doesn't really matter. So if matrix A O comma N, okay, no, if the F part of it exists. Right? Isn't that right? Yeah, so if, then end. If the F part, matrix A, O, N, okay, then that means we're going to test both of these directions. So if it exists, let's see, what do we do here? We called the subroutine right away, or what? Okay, I guess we do. We just call the subroutine. Go to 1. It works for me. And then we do a for D is -1 to 0. If go to end. If D go to 1. Right? Right? Isn't that right? And then let's see if F part for if go to end. So if d for d is -1 to 0. And let's see if this works. Hopefully this works. So we should be able to attack, both teams should be able to attack. White goes first, forgot about that. So both players should be able to attack the other player properly. Okay. I come up here, I move down. Now I select him. 2 positions to move to. Boom, I have a kill. Okay, so I mean, the code is essentially the same, so we don't have to really debug this one too much, or test it. I mean, we don't really have to test it too much. I think the pawns are good. Okay, I think they're good. I think the pawns are good. It's time that we check it's time that we're done with the pawns. It's time that we move on to something like the rooks or something, or the, you know what, I want to do the knights. I really want to do the knights. I do. I want to do the knights. And just to make sure, I think knights we're doing as ends, right? Not K's. So knights are 3. When we run the program, so when I walk over this K over here on the left, it'll become an N. Yeah, see? So we need to fix that really quick first. We'll just take a second. So this is an N, not a K. And then this is an N, not a K. This is an N, not a K. And this is an N, not a K. There we go, we got our knights in position. There we go. Okay, so let's go and go down to our code here. And we're going to have to count, because we want to be in, let's call this 0 space. So outside of this branch, this if, up here it's 0. So inside this branch it's 1, 2, 3, 4, 3, 4, 5, 6, 5, 4, 3, 4, 5, 4, 6, 5, 4, 3, 2, 3, 4, 3, 4, 5, 6, 5, 4, 3, 4, 5, 6, 5, 4, 3, 2, 1, 0. I mean, this kind of makes sense because we're right before the part where we officially move the piece. Hold on. Or before we select the piece. Okay, so we have to put essentially everything. Hold on. Let's try this. If F0, we're going to say knights go here. F0, we'll do rooks, or we'll do kings after we do knights. Okay, F0, let's see, what other ones we have? We have the bishop, we have the rook, and we have the queen. We want to combine those, I think, using subroutines for the diagonal and stuff, which will kind of be crazy, but it'll be cool. But we'll do knight and king first, and then we'll do, yeah, let's go ahead and do rook, F0. These are comments, by the way. I'm just saying F0 so it doesn't do anything. Rook, bishop, queen. Yep. Okay, so if is it P that we're dealing with here, or what? Oh, you know what? Oh, you know what? It won't enter that, though. Oh, but you know what? We mess with P. So we don't want it to think, okay, we don't want to mess with P. This is tricky. This is tricky. Because we mess with P inside of there, and we don't want to do that. But because we call, see, we call, when we call this, do we change P at all? I think we do. I think we do. And that's a problem. So I could use R. I could use R. Or I could use else statements. That would also work. Yep. I mean, if I use else statements, then the branches, if the first branch happened, then I don't have to worry about P changing and then the second branch happening. So I suppose instead of having this end here, I could have an else and then put another end. Right? So there's an else. And then I can put another end. Yep. And then I can put an else here. And then I can put another end here. Okay. And then we can do an if king type thing or whatever. That'll work. Okay, so if P equals, I believe it's 3 or 0.3. Okay, then we got our king code right here, or our knight, sorry, our knight code. So we want to try, I believe it's 8 places around us. So we want to add 2 to each coordinate and 1 to the corresponding new coordinate, or 1 to the other coordinate for each of those. Okay, so we're going to have 2 plus x, 2 minus x, 2 plus y, 2 minus y, and then 1 plus or minus for each of the remaining coordinate for each of those. So, and then we should just be able to, so this should actually be really simple. We should just be able to call the subroutine for each of those. So it should actually be pretty simple. In fact, I might be able to just do it in a loop. For b is 1 to 8. Or actually, let's try this. Let's do -1 to 1 in steps of 2. And then we'll use e here. And we'll say -2 to 2. And -2 plus what? 5 is 2? 1, 0, 1, 2. Right? Or 2. Wait, what am I saying? 5. It's 4. And then for each of those, we'll try the x value. And the y value. Okay. So we'll have x plus b and store that into n, and we'll have y plus e and store that into o. But then down here we'll have x plus e and store that into n. And then we'll have y plus e, or y plus b, and store that into o. Catch my drift? So that'll get us all 8 possibilities, because the loop will run 4 times, and we'll kind of do like the symmetry on the x and y for each of those. So yeah, then we just call the subroutine, I think. I believe. I don't even think, hold on. Do we even need, is it x plus y or is it I and j? Right? Which one was it? Yeah, see, they do everything Or I mean, they. I said they because I kind of made my subroutine such a black box that's kind of a good thing in this case. Int p equals not int q and f part p or not p. Then c+1 stores. Yep. O and N. Okay, so let me check, where do I call it again from? Or what variables do I use to find O and N? Is it not J? And I, is it X and Y? Why is it J and I? I thought X and... Oh no, J and I. Hold on. Oh, you know what though? Huh. J and I, it's almost like I don't need them because it's not like I'm changing X and Y. I don't know why I need J and I in the first place. It's not like I'm changing them. I'm using N and O anyway, so I don't know if I actually need those. But they should be changed as it is, and to stick with what we have there, we should use I and J. I suppose. Yeah, so all we have to do is call a subroutine and it will do everything for us. It'll add them to the list, it'll do everything. So we just have to do, so N and O are set, so we just have to do for D is -1 to 0. If D go to 1, end. Whoa, if this works, that'll be so fast. Because I just programmed the nights with just this little loop. Think about that. Just this little loop, and I programmed the nights. Just this little loop. Which is kind of crazy. It's kind of awesome, though. Okay, so for D is -1 to 0. Yeah, let's try it. Okay, that doesn't work. Is it because we only had the white knight selected? Oh no, that's a king. That's why. Let's select this knight. What? That's why I love subroutines. And black one better work. Better work. Oh, come on. Don't tell me I put it inside the loop where it's... No. Don't tell me I did that. Don't tell me I did that. No. 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 Oh. Okay, let's try to move this knight. Oh, that is just so cool, though. And I didn't have to, like, barely write anything. Like, I didn't have to barely write anything. Like, all I did was write that loop. Uh-oh. That's not right. That doesn't make sense. You can't move... Wait, what? Wait a minute. What? That doesn't make sense. You can't move here. Okay, that doesn't work then. I'll have to double check my loop logic to make sure that... Yeah, let's try to move this knight again and see what happens. What? 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 Why does it try to move right? And then up there. Okay, so going up it looks like it works. But why? Okay, so there's a couple problems. And I think they're just, I mean, they're not problems with the subroutine, they're just problems with what I just wrote, that's all. That was kind of weird. That was kind of like silly. I might be able to get away with moving another end up here. Because I think the issue was I checked the color, right? No, if F part, no, I should have been able to, that's not right. I should have been able to select the black ones, unless those are pointing up. Hold on, it might be a weird issue. If B goes from -1 to 1, and E, I could start the game out by putting a knight like in middle of the map just to like test this, because it'll still work the same if I just put a knight in middle. It's not going to change anything, except the starting output, which I've hard coded, but that's okay because we shouldn't even be doing that anyway. But the subroutines, something silly is going on. Okay, B is -1 and E is -1. Whereas E is -2, then that means right, we're checking -2. And then for B is -1, we're also checking +2. So that doesn't make sense why it wouldn't work. I plus B. J is the Y coordinate. What? What? That doesn't make any sense. Why wouldn't it work? I must be not understanding that or something. Let me go ahead and change this, so if 0 debug, that's just like a comment right there. So we're going to put a 1.3, or not a 1.3, a 0.3 into matrix A. Let's go ahead and go with 5, 8. Okay? 5, 8. 5, 8. Oops. That's all the way over here, isn't it? Yes, it is. But it's okay. Oh, wow. What? Down 1, left 1, 2. Okay, but it should also be here. It should be up 1 and left 2 as well. Why would it go here? Okay, I don't know what the issue is, but here, let's forget the 8. I don't know why I did 8. 5, 4. I did this wrong. I definitely did this something wrong here. Something wrong here. Something is wrong here. If D go to one end. If D go to one end. Okay, my I's and J's are not changing. This is silly. I should be adding 1 to the -1 to 1, -2 to 2. Why? What is wrong with that? I plus E and N, I plus B and N. Oh, wait. Do I need to do 4 of these lines? I need to do 4 because there's only 4. No, wait. So for B is -1 to 1, that's 2 cases. And then within those 2 cases, there's 2 cases. So what's the problem? -1 plus 2 is 1, right? And -2 plus 4 is 2. Right? So I don't understand why it wouldn't work. And I don't understand why does it go up 1 and into the right one. That's just weird. That just doesn't make sense to me. -2 plus 4 is 2. Right? So why does it go up into the right one? I'm not changing I and J. Am I? Like, what? What could be going on here? N and O. Yeah, something silly's going on. Because it's not... It's not adding... I don't alter those values anywhere, do I? Do I use E or... Do I use B anywhere? I mean, if I use B somewhere else, that could mess with it. I suppose I could try using F instead of B. And see if that fixes it. Let's see if that fixes it. If that fixes it, then I know what the problem was. Nope. Same issue. Am I using E anywhere else? How is it that it's getting... Okay, let's deduce what's wrong here. The Y values... The Y values are correct. The Y values are correct, I believe, and I think the X values are what are messed up, based on what I see there. So that means the N's are getting messed up, the I's. So the F, still getting screwed up, regardless of whether it's an F or not. The F is -1 to 1. -2 plus... -1 plus 2 is 1. The F and the E. I don't think those are getting screwed up, but... What I could do is I could display I could try to do something silly like this, and we'll see if it helps at all. I might not be able to read it. -1, -2. Alright. Yeah, something something is wrong with the well, let's see, 1, -2. That seems like it should be a... Well, let's see what N and O are. N is 5, and O is 3. Where is that on the screen? 5 and 3. Where's 5 and 3? That's right here. Well, that doesn't make sense. Well, what's I and J? 4 and 5. So something's not adding up here. Let's go back down here, figure out what it is. For F is -1 to 1, 2. I don't know what the problem is. I don't know why. I and J must be getting messed up or something. Because it's just... N and O. List 1B stores N. Urgh. What's going on? Why doesn't it work? It should be working. If N is greater than or equal to 0 and N is... Ooh, that's one problem we have here that I never realized before, is these should be greater than or equal to 1, not 0. I think I caught that. Well, actually, it wouldn't have been a big deal. I would have just got a out of bounds error and I would have caught it then. I would have been like, what? Oh, okay. But it's funny, I didn't... Oh, wait a minute. Here's our problem. We can't use E. Okay, so it wasn't the B that was screwing everything up, it was the E. Yep. That's what our problem was. Okay, so that's a variable we can't use. Anyway, so instead of E, we're going to use B. E, we're going to use B. E, we're going to use B. We're going to use... Oh, nice. Look at that beautiful thing. Oh, look at that. Look at that. Look at that. Just, would you look at that? Watch, watch. Boom, 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 boom. I can move in 8 different positions right now. Boom, 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 boom. and I moved, and I attacked. Did you see how beautiful that was? Did you see how beautiful that was? Did you see the beauty of that right there? Did you see that? Did you see that? That was just awesome. That just blew me away. That is exactly what I wanted to happen the first time. But no, I had to use E, because I'm dumb. Why did I have to use E the first time? Why? Okay, so we still have to do the king, the rook, the bishop, and the queen. So... yeah. Let's go ahead and do the king. We're going to say if, then, else, end. Okay, so here's where we check if it's king. So if matrix A or I'm sorry, are we using P? If P equals 0.3, okay, so if P equals 0.6, okay, then, oh, and we never actually finished the pawns, but we should be able to do that. We should be able to do that after. Yeah, we should be able to fix that. I do want to fix that because we do want to at least be able to start the game correctly and everything. Otherwise, you won't really be able to play it. So we will have to fix the pawns still before we finish this. So if P equals 0.6, that means we're the king. And we want to call the subroutine on 8 places around ourselves. So I've got an idea of how we can do that. What we're going to do is we're going to do 9 places, and then we're going to just do an if statement to make sure that we're not in the same place that we started. So I'm going to do 2 for loops. Okay. Do 2 for loops. And we're going to use B and F, just like we used before. And we're going to go from -1 to 1. And we're going to do if B or F. That's a good way to put it. If B or F. So if both of if either one is non-zero, then we're going to do what's inside of this middle part here. And that's there we go. This is we did the logic for the king pretty much as easy as that. Look at how easy this is. Watch how easy. Watch how easy. Now we just do 4. Oh, this is so easy. This is so easy. We do B is -1 to 0. If B, then we go to 1. Bam! I think I'm done with the king. In fact, let's make this even quicker by going to up here. And where's our debug? Let's put our king as the center of attention. What is he, 0.6? Let's put our king right in the middle there. Ready? Bam. Oh, come on. Oh, oops. I tried it a little too quick. I forgot to add the coordinates, didn't I? Where's our king? Where's our king? Where's our king? Where are you? Where are you? My bad. My fault. What did I do? What did I do? I am so goofy. I thought all I needed to do was put the for loop. No, okay, so I plus... Sorry, it wasn't literally that easy. I needed to do 2 more statements here. I plus B and J plus F. And then I is the N and J is the O, which are X and Y. There we go. Okay, now let's test our king. Ready? Oh, come on. Come on. Why? 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 Why doesn't it work? Why? Why? I must be reusing another variable or something because there's no reason why this... 3 again, what? Okay, so... hold on, let's go back down to the knight. Let's go to the knight. Where's the knight? P equals 0.3. I used F and B. What did I use for the king? B and F. Why? 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 What's wrong? Oh, derp, 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 derpity derp. That's why. Okay, ready? Magically, the king works. 8 moves. What's up? What is up? What is up? Did you see how easy that is? This is what I love about programming chess. This is the one good thing about programming chess. Once you get it to work, I'm telling you, once you like do all the hard stuff. See, people don't realize this when they're programming. They always say, especially with my personality, people always say that I make things, they quote, you make things way harder than they are, or something like that. So, but my argument is, I get over this like hump thing. Like, imagine like this, like kind of like this hump. Like, dude, like when you get over the hump, everything like is easy after that. And I mean like more than what would be possible if you didn't go over the hump. I mean, there's a reason why you go over this hump. It's not, oh, I just want to do the hump first and then like do the easy stuff later. No, I mean, if you don't go over this hump, then everything will actually get exponentially harder and harder and harder rather than like level off and kind of be like easy. That there's a reason to go over the hump sometimes. Trust me, there is a reason to go over the hump sometimes. So we are done with the king. We are done with the king. We are done with the king. Okay, I want to make 2 more subroutines. And you're probably thinking like, why make 2 more why? Just why? Why would you make 2 more subroutines? Okay, I'm gonna make a subroutine to do the rook, because it's gonna make it so easy when I do the subroutine for the rook and the bishop. Then when we do the queen, we literally just call both subroutines. That's it. Like that's literally like the queen's code will be call cross. It's going to be the cross, and then it's going to be the diagonals, which is going to be subroutine 2 and 3. That's that's going to be the queen's code. It's just going to be cross diagonals, done. That's it. Because it'll already be programmed for the rook and the bishop. So, yep. Might as well. So let's put another end here. And let's put an if here, and put a then here, and put an else here. And we want to see if P is equal to, what's the rooks again? Isn't it 0.2 or something? Isn't that right? 0.2. Yeah. So rook is 0.2. Now I want to say for, since we'll be calling lots of subroutines, I'm going to use F. No. Okay, so E's used. I'm going to use D in the subroutine. So let's just use F, yes. Let's say for F is -1 to 0. If F, then we call 2, okay? You think I'm crazy. You think I'm crazy. But watch how easy this is. You think I'm crazy. Watch. I'm not even gonna, here, let's not even program subroutine 2 yet. Let's just go ahead and go straight to the bishop. Let's do the bishop. Let's, come on. Just watch. Just watch. If you don't believe me, just watch. Just watch how easy. This is why you do the humps. Okay, so I'm gonna add the end here. And I'm gonna say if, I'm gonna say then, I'm going to say else, okay, and this will be the bishop's code. So if P equals point 0.4, right? And let's do the queen's code even. So if, then, I'm going to put it, I'm gonna put an else. Okay, just to check the case. So I'm gonna say like, display. Oops. I'm gonna say like display like 5 divided by 0, because this line should never happen. So I want it to crash if that happens. I actually want to see it like crash there and be like, oh wait, how did it get there? So I want it like, and trust me, this is if you're not used to programming, people actually purposely, especially if they're like for example, like you're trying to make some code that's going to work for like NASA or something, you like make things very explicit to see where you don't want to return incorrect like double floating points and stuff like that. You want to know exactly that your code, it works for all bounds and stuff. So they purposely try to like make it very easy to catch if something went wrong. Like if something did like for sure should not happen, like they make it very explicit, like this should not happen, and if it does, like boom, like it's like a big warning. And you can put like, instead of me just saying display 5 divided by 0, I should like put like a description of like why like the code should never have reached there, and there's definitely something wrong with the code that needs to be fixed if it did reach there. So you can like find out like, wait, it shouldn't have happened. So obviously there's either a design flaw or something like of the such. So anyway, if P equals 0.5, then that's the queen's code. Okay. So here we did F is -1 to 0. If F go to 2. Okay. For F is -1 to 0. If F go to 3. So there's the bishop. Okay, now watch for the queen. Watch how I do the queen. If, or I'm gonna just do both things. In fact, I can put them both in one. Watch this. Watch this. Watch this. This is kind of cool. So I can do for f is -2 to 0. And I can say if f equals -2, and here I can say if f equals -1, then you go to 2 or you go to 3. And there we go. The queens. Okay, so now the bishop, the pawn, now they all just depend on their subroutines. Oh, you know what? Wait. I spoke too soon. Did I speak too soon? No. No, I'm fine. No, I didn't speak too soon. Because I'm starting with I and J in these subroutines. I'm not setting no, like, N and O and stuff. Nope. Okay. So, we're going to do a label. 2. We're going to do an end. We're going to do a label. Jeez, what's a label? Is it like... What value is it? 9. 3. End. Okay, so label 2 is going to be cross. And label 3 is going to be diagonals. So essentially, from label 2, all we have to do is call the subroutine for going in every direction till we get to the end. So, and we can't change F, and we can't use E. Like, pretty much we can use B, and then like new variables. So we can use like B and like H or something. But check this out. So check this out. Okay, so for B, is, we'll say -8 to 8, right? So I'm just going to do like a full cross no matter where you are on the thing. No matter where you are on the... No matter where your rook is, it's just going to go from -8 to 8. So if not B, so this will only work when it's not 0, okay? And then I want to check, of course I have to check I don't even have to check the bounds actually, because the subroutine will do that for me, so I don't even need to. Oh wait, I lied. I lied. I can't do it like this, my bad. We're gonna have to do it the other way. So, because I can't check the whole thing. Oops. Oh, great. Label 2 for end. Okay. So I start from 1 and I go to 8. But if I hit something, I have to stop. I can't try to add things after that. If I hit the wall, that's one thing. Like, it doesn't matter, but to check if there's a space there, I need to know that it's not the wall anyway, so I have to check for the wall here. I don't have a choice. Okay, so this will check both positives, and this will check both negatives. So if I plus b, oh, you know what? I don't need that. I can just do it all in this loop. So if I plus b is less than 8, or less than or equal to 8, okay, that means it's safe to check. Okay. If I minus b is greater than or equal to 1, then it's safe to check something here. If j plus b is less than or equal to 8, then and then I can say if j minus b is greater than or equal to 1, then end. Okay, so that here we're checking to make sure that we can check whether something is there, and we want to stop after we want to set b if it is true that there's a piece there, then we want to set b to like b8 or something, so that we don't keep checking, because we have to stop when we get to one piece. So if matrix A of I plus B and I is the x value, so it's j comma I plus B, if the fractional part of that if the fractional part of that exists, then we want to set we want to set 8 as b, because we want to skip it. Oh no, we can't. Shoot. We have to do individual loops. Yep, we'll have to do individual loops. Because if you're exiting a loop, in fact, there might be a break or something. No, I'll just do 8 stores B. That works. But I'm going to do another end, and then I'm going to do a for B is 1 to 8 again. Yep. And then here I'm going to do the same thing. I'm going to do end. I'm going to do for B is 1 to 8. And there we go. That works. It should work. So if the fractional part exists, then I set 8. And that's going to be the same here. So if the fractional part of j I minus b the fractional part of matrix A, then 8 stores B. Whew, this is crazy. And then here we put if the fractional part of matrix A, J plus B, comma I, then we're going to store 8 into B. And then here, if the fractional part, again, oops, if the fractional part of matrix A, J minus B, comma I, then 8 stores B there. There we go. Okay. So, if I plus B is less than 8, then that means we can do, add, or we can just do the subroutine on N and O. So this is so J stores O, I plus B stores N, and then you need 4 lines to do the subroutine. So 4 and if go to, and I think I was planning to use D here. So D is -1 to 0 if D go to 1. Yeah, I think that I have to do that for each one of these. So that's the first one. I have to do that for a couple more. So yeah. So 4 if go to end, and the I and the J, so I minus B stores N, J stores N, or O I mean, for D is -1 to 0. If D go to 1, okay, I'm done with that. Okay. So 6 lines here. So J plus B stores O, and I stores N. We got a 4. D is -1 to 0. If D go to 1 and then one last one here. So 6 lines, 1, 2, 3, 4, 5, 6. The last one's an end. This one's a go to 1. This one's an if. D, this one's a 4. D is -1 to 0. This one is J minus B store as O. I store as N. And who knows if this works? Who knows? So what's the piece? It's point. The point. What's the rook? We're testing the rook here. It's 0.2, I think. Okay, well. Oh, dude. Dude, it works. What? It works. What? It works. Is that 11 moves? Let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Dude, it works. See? What did I say? What did I say? Okay. So check this out. Let me blow your mind. Let's put the queen out there. Let's see if the queen works just like the rook. The queen should work just like the rook right now. So let's go ahead and put 0.5 into matrix A. We'll say 7, 4. So let's go ahead and put the queen. Oops. Looks like she works. I should have done not 7, 4, but 5, 6 is what I was looking for. Oh man, the queen works, dude. The queen works. The queen works. Look at this. I'm almost done with chess. I'm almost done. What now? Although it doesn't check. Okay, so it doesn't check all the other players' moves, whether they're valid, because, and that would be so easy. I'm telling you, this is so easy. If you functional, this is what programming is all about. If you have functions and stuff, you can do, it doesn't even matter how in-depth the logic goes. I mean, it kind of does matter, but you can almost arbitrarily, if you just have the right type of like syntax and right, trust me, most people do not most programmers don't even understand the power behind the right type of like programming language, etc. They'll build like a really nice, parsing system, but it won't have like recursion and stuff like Minecraft World Edit, for example. You can plot pretty much any shape you can imagine, but they're one step away from making it like infinitely more powerful, and it's not really much they have to add. They just have to make it, recursive. But we're almost done. We have the pawn to fix, but we're almost done adding all the pieces. So I'm about to add the queen. Literally, I'm going to add the queen and both the queen and the bishop at the same time. I'm going to add the queen and the bishop. Their moves at the same time. So I'm going to do the b equals 1 to 8 thing, but I'm going to add, so essentially I'm going to copy, you know what? I might be able to flag this. I might not even have to write this last, hold on. Woo, if I use an extra variable, because I got extra variables. Let's just try this. Let's just try this. So this is what I'm claiming. This is what I'm going to attempt to do. Okay? So I'm going to attempt to salvage, to use this. Salvage just means it's trash already, but it's not. I'm going to attempt to make this bi-functional. This function, this subroutine label 2. I am going to make it depend. You're going to pass another variable. We'll say the variable, we'll just pass it G. Screw it. We got so many variables. We'll pass it G. If G is 0, then we multiply it by B, and it has no effect, which is fine. But if G is 1, we multiply that by B, and it gives us a diagonal instead of a straight. So here I'm going to add, so J, I'm going to add G times B to it. You get where I'm going? I'm going to add G times B. Same with this. Wait. I gotta make sure, hold on. So if I'm adding, okay, so if I'm adding to both, then that means I need to not add to both again for the next time. So I need to add